Yes,
isn't it?
sir.
What is the condition for me?
Sir, it's
A
gonna
round
slow
disk of,
down, sir. Wait.
the round disk, we are getting it right now, what? A round disk of moment of inertia I2 about an axis is perpendicular to the plane and is passing through the center. So for this one, the moment of inertia is passing through center and perpendicular to the plane. So what will be the moment of inertia for the disk beta about an axis? Iz is equals to your m into your r square divided by 2. I hope you remember this one. So it is
Yes,
being
sir.
placed over another disk of moment of inertia I1, which is rotating with an angular velocity omega about the same axis. The final angular velocity of the combination of the disk is how much? So initially angular velocity of this one is 0. This one was moving with omega. Moment of inertia of this one is I1. When you keep this one on this part, one above the other, the combined moment of inertia is I1 plus I2. And final angular velocity is omega dash. We need to find out this final angular
Yes,
velocity.
sir.
What happens generally, final angular velocity increases or decreases? When mass is increasing, moment of what angular velocity of that one
Decreases.
obviously decreases. Is there any
Yes.
external force
Yes.
acting on the system? No, Gada.
No,
The
sir.
moment you are keeping on this one, the velocity is being changing on its own. You're not doing anything. You're just keeping another system on this one. So there is no external force acting on the system right now. As there is no external force, initial angular momentum must be equal to final angular momentum. There
Yes,
is
sir.
no torque. If there is no external force, means there is no torque also. That means angular momentum is conserved. Angular momentum is conserved. Initial angular
Observe.
momentum must be equal to final angular momentum. So angular momentum formula in the L is equals to I into omega kada. So this one is I2, omega value is 0. So it is I2, omega value is 0. Plus first one is I1
Yes, sir.
into your omega. Then finally both are combined. So I1 plus I2 into your omega dash. Isn't it? So this will become
Yes,
for
sir.
me I1 into omega is equals to I1 plus I2 into omega dash. So omega dash is equals to I1 omega divided by I1 plus of your I2. So this will be the final angular velocity. Is it clear?
Yes, sir.
Is it clear? Such type
Once
of
can you
model
show the
చాలా
next?
ఉంటాయి. ఏనానా?
ఒకసారి ఆ సొల్యూషన్ చూపిస్తాను.
Net external torque is 0 beta. Net external torque is 0. So
Yes, sir.
initial angular momentum must be equal to final angular momentum. That means angular momentum is
Yes, sir.
conserved. Angular momentum is conserved.
Okay, sir. Thank you.
Next one, Jodu. Inko question, Jodu. This one is also a very good question right now. A disk of moment of inertia I1. We got a disk of moment of inertia, how much for me? I1, which has been rotating in a horizontal plane about an axis passing through center and perpendicular to its plane with constant angular speed omega 1. Same like previous case only. We got a disk of moment of inertia, how much beta? I1, which is rotating in a horizontal plane about an axis passing through its center and perpendicular to its plane with a constant angular speed, how much? Omega 1. And we got another disk of moment of inertia I2, which is having zero angular speed. Okay, second one moment angular speed
Yes,
into
sir.
0. Isn't it? And it is
Zero.
placed coaxially. Coaxially means one above the other. Coaxially means one
Okay.
above the
Yes.
other on a rotating disk. Now both the disks are rotating with a constant angular speed of your omega 2. So the energy lost is asking right now what energy lost by the initial rotating disk is equals to your how much? Initial rotate out kada. So it will lose the angular
Yes,
velocity
sir.
and it will also lose the energy. So once again the question
Yes,
to
sir.
the disk of moment of inertia I1 is rotating in an horizontal plane about an axis, which is being passing through the center and perpendicular to its plane with a constant angular speed of omega 1. Another disk of moment of inertia I2 having zero angular speed is being placed coaxially on a rotating body. Ante first body which has been rotating, then paina second body which was at rest we have been keeping. Now when both the disks are been rotating with constant angular speed omega t, then energy lost by the initial rotating disk is equals to your how much? Okay, so this is a relation. So these are the options which has been given. Let us try to see the conditions better. See, this is the first situation. First one is rotating with n. This is a disk. Moment of inertia for the disk is how much? Again, mr square by 2. Angular
Divided.
speed of this
Yes,
one
sir.
is omega 1. Moment of inertia is I1 plus another disk right now. Then moment of inertia in the I2. This is at rest beta. Omega is equals to
Yes,
0.
sir. It's not there.
Yeah. Now you are keeping this one above the other like this. So when you are keeping one above the other coaxially, Now angular velocity from omega 1, it will change to what? Omega 2.
Yes, sir.
Now moment of inertia, both of them are added here, I1 plus I2. They are kept one above the other. So again, no external
Yes.
torque is acting. So as external torque is equals to 0. So angular momentum is conserved. Angular momentum is conserved. Angular momentum is conserved. Angular momentum is conserved means what? Initial angular momentum is equals to final angular momentum. Now let us try to see initial angular momentum. We already know the relation L is equals to what? I into omega. So this one is I1 into omega 1 plus I2. Then angular velocity is 0. That is equals to I1 plus I2 into omega 2. So I can get the value of omega 2. Omega 2 is equals to how much for me? I1 omega 1 divided by I1 plus I2. Is it clear?
Yes, sir.
Now, what is the initial kinetic energy of this one? It is rotating cavity. For rotational mechanics, we know the rotational kinetic energy formula is half into I into omega square. So it is half moment of inertia I1 into angular velocity omega 1 square. The kinetic energy is 0. Final kinetic energy is this one. K final is equals to half. Both of them are combined. So I1 plus I2 into your omega 2 square. Antena? So we got
Yes.
initial kinetic energy, we got final kinetic energy. So he's asking us to calculate the loss. Loss means initially it will be having more gada. The moment you keep the mass, what is happening to its speed? It increases or decreases? It is decreasing. That means omega 2 is
Decreasing, sir.
decreasing, isn't it? So as mass is been increasing right now, angular velocity of that one will be decreasing. So final kinetic energy of this one is also less. So K initial minus K final.
Yes.
Okay. Now we already got here right now K initial value. So loss is K initial minus K final. Initial is half into I1 omega 1 square minus K final is half I1 plus I2 into omega 2. Omega 2 value వచ్చింది కదా ఈ వాల్యూ తీసుకొచ్చి దీంట్లో వేసుకో. సో omega 2 is equals to I1 square square కదా omega 2 square కాబట్టి దీన్ని స్క్వేర్ చేయి. I1 square omega 1 square divided by I1 plus I2 whole square. E square, ED, and this one will get cancelled. So what is the answer I'm getting? Half I1 omega 1 square minus half I1 square omega 1 square divided by I1 plus I2.
Right.
Okay, now?
Yes, sir.
So this is your loss. This is the way how do we calculate. These are all very important model beta. ఒకటి రెండు సార్లు you need to practice them. Then only you can do to some extent the problems related to this. Okay, na?
Yes.
So got an idea?
Yes, sir.
One more model based on same thing. ఇక్కడ వరకు ఏమొచ్చింది మనకు కే ఫైనల్ మైనస్ ఆఫ్ యువర్ కే ఇనిషియల్ దీన్ని ఇంకా సింప్లిఫై చేసుకోవచ్చు కదా దీన్ని ఇంకా
Yes.
సింప్లిఫై ఎలా చేసుకుంటాడు హాఫ్ ఐ దీంట్లో హాఫ్ ఒక ఐ తీసుకోవచ్చు ఐ కెన్ టేక్ ఓన్లీ వన్ ఐ అండ్ ఒమేగా 1 స్క్వేర్ విల్ బికమ్ కామన్ సో ఇఫ్ ఐఎమ్ టేకింగ్ దట్ వన్ half I1 omega 1 square into 1 minus I1 divided by I1 plus I2. Correct like that?
Yes, sir.
LCM of this one. If I am taking the LCM of this one, change in kinetic energy is equals to half I1 omega 1 square, 1 minus I1 by I2. I1 plus I2 is I2 by I1 plus I2. Okay. So change in kinetic energy, how much you are getting right now? Half into I1 I2 by I1 plus I2 into your omega square part of relation. Okay.
Yes, sir.
Sure. One more model based on this one. Very, very good question. Beta. See here. We got two discs of same moment of inertia. Two discs of what? Same moment of inertia. అంటే రెండింటికి moment of inertia is I. Rotating about their regular axis, passing through the center and perpendicular to the plane of the disc with angular velocity. First one is moving with angular velocity. Second one is rotating with angular velocity omega. Now both of them are rotating beta. They have been brought into contact face to face. అంటే same like previous. Coinciding the axis of rotation. అంటే ఒకదాని పైన ఒకటి పెడుతున్నాం. The expression for loss of the energy during this process will be equal to how much? Is the question clear? We got
Yes,
two
sir.
discs of the same moment of inertia beta about their axis passing through the center and perpendicular to the plane of the disc. With angular velocities how much? Omega 1 and omega 2.
Omega
They
1,
are brought
omega.
into contact face to face. They brought in contact face to face, coinciding the axis of rotation. The expression for loss of energy during this process will be equal to your how much? The expression for loss of your energy during this process is how much? Same like a previous case beta. See, this is the first body. Moment of inertia of the first body is how much? I. Second body of moment of inertia is how much also? I. This one is moving with omega 1. This is moving with omega 2. Now both of them are combined. They kept one above the other. So angular velocity of this one is how much right now? Omega. And I
Yes,
are
sir.
kept one above the other kabatti. The total moment of inertia will become how much? 2I.
2i. Yes, sir.
Now, as there is no external force acting on this one, so torque will be equal to how much?
After
Torque
0.
external is equals to 0 because there is no force
Yes,
which is
sir.
acting perpendicular to it.
Acting.
Is
Yes,
it?
sir.
So initial angular momentum must be equal to final angular momentum. We already know the formula L is equals to I into omega. Derivation by the manam L is equals to I omega.
Yes, sir. Yes, sir.
Chalo. So this one is I1 is nothing but I, omega 1 is omega 1. This one angular momentum of this one is I into your omega initially. Initial means this two, isn't it? Then final means these two are added up. I plus I into final angular velocity omega. So in this one I can take I common omega 1 plus omega 2. I plus I 2I into your omega. So what is the final angular velocity? Omega is equals to omega 1 plus omega 2 divided by 2. Is it clear?
Yes, sir.
Okay, so we have got the final angular velocity is equals to your omega 1 plus omega 2 divided by 2 part of relation. Now, what is the loss in energy? Loss in energy. That means initial kinetic energy means initials unnaya. So half into I into omega 1 square plus half into I into your omega 2 square.
Yes, sir.
So in this one, half I is your common. This one is omega 1 square plus of your omega 2 square part of a relation. So this is your initial kinetic energy.
Minus.
Then final will be equal to how much better? What will be the final kinetic energy? That is half I1 plus I2 is 2I into omega square. Yes, beta? Did
Yes,
you
sir.
ask me?
Yes, sir. That only, sir. I was gonna say.
Yeah. Final will be equal to how much beta? Half into 2I into your omega square. No loss adugutunnadu kabatti delta k is equals to k initial minus k final. K initial how much I got? Half I into omega 1 square plus omega 2 square minus half of your 2I into your omega square. In this one, half I and half I we can take common. This one is omega 1 square plus omega 2 square minus this one is 2 omega square. Ante kada? Half I,
Yes,
this
sir.
half and I took it as common. So it is omega 1 square plus omega 2 square minus in this one 2 into omega square part. Okay, this already omega I got in the problem. Omega value is how much? Omega 1 plus omega 2 by 2. So I'm substituting that value here, half I into omega 1 square plus omega 2 square minus 2. Omega value is omega 1 plus omega 2 by 2 whole square. Okay, na?
Yes, sir.
No. This, if I'm squaring this one, this is omega 1 plus omega 2 whole square divided by 4. 2 square is nothing but 4. This 2 ones are and this 2 twos are will get cancelled. So it is half into omega 1 plus omega 2 whole square. Clear? So half I into this one
Yes,
is
sir.
omega 1 square plus omega 2 square minus this one is half into omega 1 plus omega 2 whole square. Now I can take this 2 common right now here. So in order to take 2 common, I can multiply here with this 2. So this will become for me 2 omega 1 square plus 2 omega 2 square minus this is in the form of a plus b whole square beta. So it is a square plus b square
Yes, sir.
plus 2 into your ab form. So omega 1 square
AB.
plus
Yes, sir.
omega 2 square plus 2 omega 1 omega 2 divided by 2. Okay, now. So this 2 if it is coming out, this will become for me 1 by 4 into I. So in this one, anything is getting cancelled, you see right now. Omega 1 square plus omega 2 square part of relation. This is divided by 2. Gada.
Yes, sir. We can actually do this, sir. 2 omega 1
Yeah.
square minus omega square.
Omega square. So that will be equal to how much for me? Omega 1 square. And this is your
Yes, sir.
omega
And
2
2
square.
omega square,
Minus,
2
yeah,
square
this will get
minus
cancelled
omega.
in. Yeah, so it will be a 2
Yes,
times
sir.
of omega 1, omega 2 part of a relation. So now it is in
Yes,
form of
sir.
what? A square plus b square minus 2 into your ab
Yes, sir.
form.
Yep.
So I can write
Yes,
1
sir.
by 4 I into a minus b whole square. It is omega 1
Yes, sir.
minus omega 2 whole square. Just little bit mathematical calculation has been required better, but otherwise the problem is
Yes, sir.
good type of a question only basically. So I hope you can do such type of a
Yes.
questions.
Yes, sir.
Next question. A particle of mass m is been moving with velocity v. A particle of mass m is moving with velocity v on a line y is equals to x plus 3. Y is equals to how much for me? X plus 3. Find angular momentum of the particle about the origin. What we need to calculate? L. Angular momentum formula in the for a particle. L is equals to mv into r. Particle ki.
Yes, sir.
Rotating
Yes.
body ki L is equals to I into omega. Okay. So a particle of mass m is moving with a velocity v. This is a given equation. Y is equals to x plus 3 ichadu kabatti compare it with the straight line equation beta. What is straight line equation? Y is equals to mx plus c. On the x-axis, we are taking x.
Yes, sir.
Constant is nothing but c. Y-axis is y. And slope is here. How much for me? What is the value here? 1 gada. 1 into x. So slope is nothing but of your m, that is tan theta. That is equals to how much for me? 1. Slope is represented by m. M value is 1. That means tan
Yes,
theta
sir.
is 1. So tan theta is 1 and the
Yes, sir.
theta
That is
value is
45.
45 degrees.
45.
C value is already how much for me? 3. Constant. Now can you draw the graph for this one better? For you, if I'm drawing the graph for this one, this is a constant 3 and this is a particle of mass m moving in a straight line. So this is the given condition. So this is making an angle theta. That is theta is 45 degrees. This is a particle mass m and v moving in a straight line like this one and having a positive constant. The constant on the other
Yes.
3 only. So that is the reason this is a positive constant and it will be a straight line. And it is meeting somewhere on your negative x-axis. Now this is m into v, but you resolve this one m into v beta. M into v into your cos theta. Then perpendicular distance ఎంత ఉంది 3
Yes, sir.
isn't it? So angular momentum will be equal to how much better? ఇదంతా చేయాల్సిన అవసరం లేదు. You can directly write here
Yes.
in one step. Angular momentum about your point O is equals to mv into your cos 45 into perpendicular distance is how much for me? 3. So that is equals to your m into v. Cos 45 is how much?
1 by root 2, sir.
1 by root 2 into 3. So what is the answer? 3 into your mv divided by root 2. అదే
Root
వచ్చిందా
2.
చూడండి. 3 into mv divided by root 2.
Yes, sir.
You need not use again this perpendicular distance anything. So this is your momentum m into v cos theta. దీని యొక్క perpendicular distance about your point O. అంతేనా? So this distance is how much for me? 3. Component of this momentum is how much for me? mv into cos theta. So mv cos theta into this
Yes.
perpendicular distance will give me the angular momentum. So how much I'm getting that one? 3 mv divided by your root 2 is your answer. Or else what you can do is
Yes.
you can extend this one in the backward direction and drop a perpendicular here. Okay, now if you're dropping a
Yes, sir.
perpendicular right now here, if this is theta, this one is also theta. If this is
Yes,
theta
sir.
right now for me, so this angle will become how much for me beta? 90 minus of a theta, and this will become for
Yes,
me a
sir.
theta calculation. Okay, now so like that you can take the resolving right now. If this is theta, so this will become for me resolving. If I'm resolving this d particulation, so this is your momentum and this is a perpendicular distance. If I resolve it here right now, this will become for me how much? Here it will be equal to your theta, isn't it? So here it will be
Yes,
equal to
sir.
theta. If I'm resolving this one, so this one is a 3 and this will be equal to how much for me?
Same.
Cos. Same.
Yes,
Perpendicular
sir.
distance. So theta is anyhow 45 degrees, whether you take sine or cos, it doesn't make any difference. So that is the reason we are getting the angular momentum of that particle like that. Clear?
Yes, sir.
Okay. Sure. One more problem చూడ దీనిపైన.
Sir, this is a bit complex problem, sir.
Not complex problem, but one
Means
or two
because
if
of
you
the
can
graph.
do it out. Yeah, little bit of mass has
Yes,
been
sir.
involved. But once you know the model, then you can do it out. But before knowing the model,
Okay, sir.
doing the question is little bit difficult. So, once you
Okay,
got
sir.
one model, this type of questions, you can do it very easily now. You're just comparing
Yes, sir.
with the given equation and resolving and writing the perpendicular component.
Yes,
I'll
sir.
give you one more.
Yes.
One more example. One more
Okay, sir.
example. I'll just do here right now. Yeah, so this one. A particle of mass 5 gram. Particle of mass how much? 5 gram is moving with a uniform speed of how much? 3 root 2 centimeter per second. In the xy plane
Sir,
along the line, y is equals to x plus 4.
sir,
Is better.
sir, your voice is breaking, sir.
Voice is breaking. Huh? I'm on already net only. Okay. Okay, chalo. Am I audible now, beta?
Yes, sir. Means in between it was breaking, sir.
Okay, okay. Now see this question, beta. A particle of mass 5 gram is been moving with a uniform speed of how much? 3 root 2 centimeter per second. In which plane? XY plane. Along the line y is equals to x plus 4 now, isn't it?
Yes,
The
sir.
magnitude of its angular momentum about the origin is. Answer should be in gram centimeter square per second. Now same like previous case, beta. Y is equals to x plus 4. Compare with the straight line
Yes, sir.
equation. Y is equals to mx plus 4. So C value is how much? 4. X value is x. Slope is how much again? 1. So M is equals to how much for me? Tan theta. Tan theta value is how much for me? 1.
Yes, sir.
That means theta is 45.
One.
C is equals to how much for
Yes,
me?
sir.
4. Mass is 5
Four.
grams given in the problem. 5
Yes, sir.
grams. Velocity is given in the problem 3 root 2 centimeter
Yes,
per
three
second.
rupees.
Isn't it? So everything is
Yes, sir.
been, you got it. Angular momentum use gain. This is a constant. You need to draw that graph first. So we'll get a straight line graph like this. Ante kada. This is your y is equals to
Yes.
mx plus p, isn't it? So when you draw the graph along your x-axis, you will get the graph like this, isn't it? So if you extend this one in the
Yes, sir.
backward direction, it is meeting somewhere here right now. You're making an angle
Yes, sir.
theta. Now here it is your particle of mass m, and this is your v. Momentum is in this direction, so you make a horizontal component. This will be theta. This will be mv into cos theta, and then the
Yes, sir.
perpendicular one is your how much for me?
Everything.
4.
Yeah,
Cos
this is
value.
for. See.
Yeah, mv into cos 45 into perpendicular distance. So L is equals to mv into cos 45 into 4. So cos
Yes,
45
sir.
value, you know, velocity value is 3 root 2, mass value is 5, cos 45 is 1 by
Yes,
root
sir.
2 into 4. Root 2 gets cancelled. So
Yes,
this
sir.
one is
Two
5
to
is the 15, 15 4 is the 60. So 60
60.
grams
Yes, sir.
per second, isn't it?
Yes, sir.
So now you
Okay,
got
sir.
an
Yes,
idea
sir.
how to
Got it,
do
sir.
such type of questions.
Yes, sir. Yes, sir.
Maybe there are some problems in your material better. You can even take such type of problems from your material and you can try to do it out.
Okay, sir. I'll do, sir.
So track line notice, na?
Sir, they started with angular momentum yesterday only, sir.
Okay, angular momentum started. Angular momentum is a very big topic actually, but a lot number of problems based on this one. Anyhow, chalo. Next one, small concept beta. Work and power in the rotational motion. How do you calculate the work and the power? So what is the work in the work power energy formula beta? Work done is equal to how much for me? Force into displacement.
Yes, sir.
So in the rotational mechanics, what is the role played by the force? Torque, isn't it? Here, there the displacement is S. Here the displacement is represented by theta.
Yes, sir.
చెప్పాను స్టార్టింగ్ లో చెప్పాను ఇన్ కంపారిజన్ లీనియర్ కి
Yes, sir.
ట్రాన్స్లేషన్
Yes.
కి బాక్స్ పెట్టి చెప్పాను అక్కడ ఫోర్స్ రొటేషనల్ మెకానిక్స్ లో టార్క్ అండ్ అక్కడ
Okay. Yes, sir. Yes,
డిస్ప్లేస్మెంట్
sir.
ఇస్ రిప్రజెంటెడ్ బై ఎస్ అండ్ హియర్ ఇన్ సర్క్యులర్ మోషన్ ఇస్ రిప్రజెంటెడ్ బై టీటా సో ద వర్క్
Yes,
డన్
sir.
బై ఏ కాన్స్టెంట్ టార్క్ ఇన్స్టెడ్ ఆఫ్ ఫోర్స్ tau during an angular displacement of the body from theta 1 to theta 2 is
Theta.
given by the
Yes,
formula
sir.
work done is equals to torque into displacement angular displacement that is theta
Yes,
2
sir.
minus theta 1. So
Yes, sir.
average
Got it.
work done can be calculated by the formula tau into your delta theta.
Delta.
W is
Yes,
equals
sir.
to tau into delta theta. If torque is variable, then you need to use the integration beta. If torque
Okay,
is
sir.
variable, if torque is variable, work done will be equal to integral of your tau into d theta. So limits are from
Yes,
theta
sir.
1 to theta 2. Limits are from theta 1 to theta 2, tau into your d
Okay.
theta part definition. So if torque is
Yes, sir.
constant, you use directly formula tau into theta. If
Now
torque
into
is
theta.
variable, like you use integral, like if force is
The
variable, how do you use to
integration.
write the work done? W is equals to F into dx and rasam kada variable unte.
Yes, sir. Yes, sir.
If
Yes,
it
sir.
is constant, W is equals to F into D directly will be using
Definitely. Yes, sir.
dot product. So here also this is a dot product of it. W is equals to tau into d theta. If torque is variable, you use the integration. Okay, na? So that will be the relation. Now next one is work energy theorem. Work power energy lo work energy theorem undi kada. What is the work energy
Yes,
theorem
sir.
beta? Work done is equals to change in kinetic energy. That means final kinetic
Yes,
energy
sir.
minus initial kinetic energy.
Initial
So
kinetic.
work done is equals to final kinetic energy is half into I into omega 2 square. Initial kinetic energy is half into I into your omega 1 square part of
Omega.
relation. So this is the
Yes, sir.
work energy theorem in your rotational mechanics part of relation. Okay. Na?
Yes, sir.
Next one is power. So what do you mean by power? Power is equals to work divided by time. Power is
Yes,
equals
sir.
to work divided by time. Work, how much we got still just now? Tau into theta. Displacement by time is velocity. In the rotational mechanics, that velocity is known as angular velocity. So power is equals to tau into V. Like in the mechanics, we are written power is equals to force into velocity in work over energy.
Yes, sir.
Now, in the same thing here, we are writing in the place of force star, in the place of V, omega. So power is
Velocity
equal
omega.
to
Yes.
tau into your omega, or as is a dot product. So power is equals to your tau omega into your cos theta. Okay, na?
Yes, sir. So we're just
So this is,
substituting each of the values, let's say,
yeah, each of the values and simplify the relation. That's it.
as well. Yes, sir.
Okay, na?
Yes, sir.
So this was the introduction related to your angular momentum of the given conditions. Okay.
Yes, sir.
See this question, beta. We got a thin uniform circular disk of mass capital M and radius capital R. Radius capital R is rotating in a horizontal plane. Is rotating in a horizontal plane about an axis passing through its center. Passing through center and perpendicular to its plane beta. Perpendicular to its plane with angular velocity omega. With angular velocity omega. Now two particles. Now two particles each of mass m are placed on its perimeter. Placed on its perimeter along a diameter. First of all, find the new angular velocity. Find the new angular velocity. If small m is equals to m by 2, find the percentage change. Find the percentage change in angular velocity. Okay, read the question better carefully. We have got a thin uniform circular disk of mass how much beta? Capital M. So we have got, this is your circular disk. Okay, this is your circular disk of mass how much? Capital M. Radius is how much for me? Capital R. It's been rotating in horizontal plane about an axis passing through center. And perpendicular to its plane with angular velocity how much? Omega. Now two particles of mass how much? Small m are being placed on its perimeter. Perimeter means outside along the
Yes,
diameter.
sir.
Okay, somewhere this one is right now a disk. now, and this one is your axis passing through your center, and here is right now, this is your disk right now, like this completely. Now what we are doing right now, we are keeping your two masses along its diameter, అంటే పెరిమీటర్ పైన ఇక్కడో మాస్ ఏం పెట్టామా, స్మాల్ ఏ, అండ్ ఇక్కడో మాస్ పెడుతున్నాం, ఇక్కడ స్మాల్ ఏ. యాక్చువల్లీ దీని మాస్ ఆల్రెడీ ఎంత, క్యాపిటల్ ఎం, దీని రేడియస్ ఎంత,
Yes,
క్యాపిటల్
sir.
ఆర్. నౌ యాంగులర్ వెలాసిటీ విల్ ఇట్ ఇంక్రీజ్ ఆర్ డిక్రీజ్ బేటా, చేంజ్ అవుతుంది కదా, సో
Sir,
దట్ విల్
it'll
బి యువర్,
decrease. Yes, sir.
isn't it? This is initially. Finally, when you are keeping the mass, what is the final angular velocity is asking. Then you calculate the percentage. Now again, there is no external torque because there is no force which is acting perpendicular to this one. So torque acting on the system is how much beta? Tau net is equals to 0. As tau net is equals to 0, initial angular momentum must be equal to final angular momentum. అంతే కదా. సో I1 omega
Yes, sir.
1 must be equal to I2 into your omega 2. I1 is only disk kabatti, this one is how much for me, half into m into your r square into angular velocity is how much, omega 1. Omega 1 is how much for me, omega, that is equals to I2. Now see, for this one we are having two masses from the axis, అవునా కదా. Like we can
Yes,
apply
sir.
the parallel axis theorem for this one, and you can also apply the parallel axis theorem for this one. And if I apply for the one, the another n is also same but you can multiply it with your 2. For the disk, you know the moment of inertia passing through center, and there is another particle at a distance of r from the axis of rotation. So what is the moment of
Yes,
inertia
sir.
I can write here? I2 will be equal to your ICM plus small m into your r square into final angular velocity is how much for me? Omega dash. It any times or night, two times into omega dash. Why 2 beta? Because we are having two masses. Okay na?
Yes, sir. Yes.
అర్థమైందా?
Yes,
ఇది
sir.
యాక్సెస్. Yeah.
Because we have
See,
two masses on the perimeter. That's why
we are taking
everything.
two mass because you know the moment of inertia passing through center of mass, and this is
Yes,
the
sir.
another one. We are applying the parallel axis theorem for this particle and this particle. So whatever you get for one, you multiply it with your into two, you will get the two moment of inertias right now. So I can
Yes,
write
sir.
here right now, m into your r square divided by 2 into your omega is equals to ICM is your m into your r square divided by your 2 plus of your small m into your, this one is nothing but of your r square into your 2 into your omega dash, isn't it? So if I
Yes, sir.
simplify the value of your omega dash, see how much I'm getting right now. Is anything getting cancelled beta? This r square,
M R
this
square,
r
M R
square,
square.
this r square will get cancelled.
Okay, yes,
So
sir.
it is m into your omega will be equal to, so this 2 will also go here beta. So this one is your 2 into 2, that means that will become for me how much, 4. There, so this is a
Yes,
4
sir.
into
Outside bracket.
10 by 2 plus of your small into your m into your omega dash. So
Yes, sir.
omega dash is how much for me? Omega dash is equals to your, this is omega dash,
M
this
omega
total value
divided.
will come here right now. M into your omega divided by your 4 into this one is capital M by 2 plus of your small m,
Yes, sir.
isn't it?
We can simplify inside the bracket. Also.
Yeah, inside the bracket also we can simplify this one. So inside the bracket, if
M
I'm
plus
simplifying, how much I'm getting right now? See, omega
capital M
dash is
plus.
equals to capital M into your omega divided by this omega 4 will go inside. So this will become
Yes,
for
sir.
me 2 times of your how much? 2 ones are 2 twos are. అంతేనా?
Yes, sir. That's it, sir. Yes, sir. Anza two.
ఇదే కదా. It
Yes,
is
sir.
M by
Sir,
2.
first you have to. Sir, first we have to do this, no, sir. M by two plus M. We have to simplify that. Then we'll do into four, right?
Yeah, we can also do like that one. That's not a problem.
Yes, sir.
Small m
So
value
we'll
is given
get
how much for me? Small m value is given how much for me? M by 2. That means m by 2 plus m by 2 is how much for me? M only, na?
M. Yes, sir.
Isn't it? So that
Yes,
will be
sir.
equal to 4 times of your m. That means
M.
this one will
Yes.
get
M. M.
cancelled. So this will become for me how much? Omega by
Omega
4.
by four.
Am I
Yes.
doing correct but
So
everywhere?
the decrease.
This is 2 gada into
Yes,
2.
sir. Yes, sir. Correct. Only, sir.
No, I have doing mistake somewhere. Moment of inertia when I'm taking right now there beta ICM plus of your, directly I can take two masses gada,
M R square.
two times of your
Yes.
masses instead of your one part of relation. I can multiply here directly with your 2.
2m r square, sir.
Yeah. So this one is nothing but of your 2 into your m into your r square. అంతే కదా? Into your
Yes,
omega
sir.
2 is nothing but omega dash. That means
Omega
this one
dash.
will
Yes,
become
sir.
for me mr square divided by 2 into your omega is equals to this one is your mr square by your 2 plus this one is 2 into your m into your r square into your omega dash.
Into omega.
This r square, this r square, this r square will get cancelled. So
Yes, sir.
anything is else getting cancelled right now. So this one will become for me m into omega divided by 2 is equals to this one is your m by 2 plus of your 2 times of your small m into your omega dash.
Omega
So
dash.
we need to
Yes, sir.
calculate the value of omega dash. So omega dash will be equal to your how much? This will come here right now. So it is your m into your omega divided by this is a 2 into this is your m by 2 plus of your 2 times of your small m. So that means if 2 will go inside, this will become for me m into your omega divided by 2 and 2 will get cancelled. So this will be capital M. 2 and 2 will get multiplied. So this will become for me 4m. So this will be
4m.
your angular velocity. So omega dash
Yes,
is
sir.
equals to how much I'm getting right now? M into omega divided by capital M plus of your 4 times of your m. Now you substitute
Yes,
the
sir.
value of your small m beta. Small m value is how much for me? M
M
by
by
2
2.
kada.
Yes, sir.
Omega dash is equals to your m into your omega
2
divided
ones
by
are
your
2, sir.
capital M plus of your 4 into capital M divided by 2. 2 ones are 2 twos are. Ante omega dash will become for me m into your omega divided by 2m plus this one. This will become for me 3 times of your m. Mm
3m.
gets
Yes.
cancelled. So it is omega by
Omega
3.
by 3.
So final
Yes,
angular
sir.
velocity, how much I'm getting? Initial angular velocity
Omega by 3.
divided by 3. Now what is asking?
Yes, sir.
Percentage change, na? So how do you calculate the
Sir,
percentage
less than
change?
1 minute, sir. I'll
Yeah, just so